And now this video discusses about the quick reviews on the vectors, and this is good for those that are preparing for their exams and some other things related to actually vectors. So first thing we'll be talking about the polar coordinate system as well as the rectangular coordinate system. Let's say we have a point B, and which is given us with the coordinates given as x, y. So the point B is said to be in a rectangular coordinate system. This is what we call as the rectangular coordinate system. We call it as the rectangular coordinate system. Rectangular coordinate system. And the same point P can also be presented as, a distance r, theta. This is said to be the polar coordinate system. This is said to be the polar coordinate system. And where actually r is calculated using the Pythagoras theorem, which is that of, that should be x squared plus y squared. And the theta, which is the angle, it is given as the tan inverse of, should be y over x. So this is how the point B is expressed in form of the polar coordinate system. So where r is given as this, and the theta is given as this. And for the rectangular coordinate system, x value is given as r cos theta, and the y value is given as the r sin theta. You should have that. Let's say we have the following questions. Express the following actually points in terms of the polar coordinate system. Let's say we have a point M with coordinates 2, 5. So what is this in the polar coordinate system? We know that in the polar coordinate system, the point M has to be given as r theta. And for this case, we have, for this case we have x being given as 2, and we have y being given as 5. Then now we should have r. What is the formula for r? We have it as x squared plus y squared, and which is given as, now we should have it as, what is 2 to the power 2? We have it as 4 plus 25. Now which means the r is given as square root of 29, that is. And how about the angle theta? We'll have it as the tan inverse of, that is y over x, that is 5 over 2. So what is that one? And now for this case, we'll have that of the tan inverse of, should be 5 over 2. Should be the tan inverse, that should be the tan inverse of 5 over 2. And which is given as, should be 68 point, should be 9, actually should be 0.2 degrees. So which means the point M, in terms of the polar coordinate system, it is given as the square root of 9, should be 29, square root of 9, 68.2 degrees. So this is what we call as the rectangular, should be polar coordinate system. And let's say we also have another point as well. Let's say we have a point A, and let's say we have a point A with coordinates given as, let's say, -2, let's say should be about 5. And for this case, we have x being given as, should be -2, and we have y being given as 5. The way we should have the x should be r, which is given as the x squared, and plus y squared. And we should also have the theta, which is the tan inverse of, that is y over x. So try to finish that one. And how about if we have the points in form of the polar coordinate system? Let's say we have the point B with the distance given as, should be 4, let's say 60 degrees. So how should you have this in terms of the rectangular coordinate system? So for this case, we have r being given as 4, and we have the theta, which is given as 60 degrees. And we should have x. What is the formula for x? We have it as r cos theta. And that is given as 4 times. We have it as cos 60 degrees. So now we have 4 times cos of 60 degrees. So what would be that one? It should be 4 cos 60 degrees. That is given as 2. And we have y, that is r sin 60 should be sin theta, which is r sin 60 degrees. That will be given as 4 times. That should be 4 times a sin 60 degrees. That will be given as 3 point, should be 5. So therefore the point B is given as 2, 3.5. So that is how it should be in the rectangular coordinate system. And for instance, also try to have this as well. Let's say we have a point O with a score of, let's say, 5, let's say negative 70 degrees. So what is that one? You should also have that one as well. Now let's go into what we call as the vector resolution. If we say a vector resolution, it is the splitting of the vector into components. But before we go further with the vector resolution, I want you to understand about the trigonometric ratios for the right-angled triangle. Let's say we have a typical right-angled triangle. Let's say this is a typical right-angled triangle like this. Should be that. And let's say this is should be x, should be y, rather this is, let's say this is y, and let's say this is x. And let's say this is angle theta 1, and let's say this is angle theta 2. Should be that. And let's say this is hypotenuse, which is given as h. So we have actually 3 basic trigonometric ratios. Should be the trigonometric ratios, or I can call them as the function. We have the sine function, we have the cosine function, and we also have what we call as the tangent, which is given as done just that. So on the sine, a sine is more associated with should be opposite as well as the hypotenuse. And on the cosine, it is more associated with adjacent and versus hypotenuse. And on the tan, it is more associated with the opposite as well as the adjacent. So that is about actually a tan. And now for this case, let's apply this. And in short, we can present that as a SOHCAHTOA. In other words, should be SOHCAHTOA. Trigonometric ratios works under the principle of SOHCAHTOA. That is the simplest way on the working principles behind this. And for instance, if we look at, let's say, angle theta 2, this is its adjacent side, and this is its opposite. So adjacent side of the angle, it is the side in which the angle is being measured from. And for instance, angle theta 2, it is measured from this actual line. This is adjacent to the angle, and this is its opposite side. So which means if that is the case, opposite, adjacent, that is a tan. So which means we'll have it as tan theta 2 is equal to y over x. We'll have it as that. And also on the same case, this is its opposite and this is hypotenuse. What is that one? So opposite hypotenuse, that is automatically sine. So have it as sin theta 2 is equal to y over h. And also in the same case, how about the adjacent? Adjacent versus hypotenuse. So that one will be given as cos theta 2 is equal to x over should be h. By the way, should be h here. We'll have it as that. Should be h. And also on the same case, if we are to use the other angle, which is angle theta 2, this is its opposite side and this is the adjacent. That will be given as the tan theta 2. Should be theta 1, which is equal to x over y. And this is its adjacent. This is the hypotenuse. That is adjacent hypotenuse. That is cos theta 2. Will be given as y of h. And this is its opposite, and this is hypotenuse. So what is that one? We have it as sin theta 2, which should be sin theta 1. By the way, we are having them as theta 1 and theta 1. So that will be given as, should be sine opposite as well as the hypotenuse. That is x of h. So these are the actually trigonometric ratios that need to be much aware of when it comes to the issues of the vector resolution. Let's say we have the Cartesian plane. Let's say this is a Cartesian plane like this. Let's say that is the case. And much as you know that this is the y-axis and this is the x-axis, like that. And let's say we have a vector from the origin. Let's say this is a vector r, given as that. And let's say the vector is at an angle theta with respect to the horizontal above the positive x-axis, just that. So in this case, this is the direction of the vector, much as the vector is composed of the direction, and it is also having the magnitude by looking at the length of the vector itself. So the direction, it is given as the angle theta, and the magnitude, it is given as the magnitude of the vector r. Just for the sake of interest, but we can have the vectors like velocity, that is 2 meters per second. So just 2 meters per second, that is the magnitude. And the direction, let's say to the east or at an angle so that is the direction. So you have to understand that if someone is here and someone is here, of course there is a direct path from, let's say this is a point A to point B, can be that. But if there is no direct path, some can think of moving like this way and also moving that way. So which means actually moving from A to B, it is the same way, let's say moving from A to C and from C to B. So for this case, let's say this is a vector, then apart from moving from A to B like that, it is the same way moving from A to C and from C to B. It is the same as that. In other words, the other alternatives should follow the same direction but in an opposite way. Should be but in the another direction. That's how you start and understand it. And for that case, moving from actually this point to this point, it is the same as someone moving. It is the same as someone moving along this. Can be given as, let's say, someone moving along that way and also moving up there. It is the same as that. So now in this case, what we have formed is a right angled triangle, and this is said to be the x component and this is said to be the y component of the vector r, and that we can call it as rx, and this is ry. Now the direction of these components would depend on the direction of the vector. The direction of the components must point in the other way direction, but in the same direction of the vector. So should be given as that. And the care should also be considered on the directions as well. You should have that. So using the trigonometric ratios, you can see that angle theta, and this is hypotenuse. What is the x component? We'll have it as adjacent hypotenuse. That is, now we have it as cos theta is equal to rx over the hypotenuse, which is the vector r. We'll have that and as that. Therefore, rx will be given as vector r, cos theta. And also in the same case, The y component will be given as the opposite hypotenuse, that is sine. Therefore, we can have it as should be sine theta is equal, that should be that of the vector, should be ry divided by the vector r, of which ry is given as the vector r sine theta. So this is how we should have to resolve the vector into components. So this is its y component and this is the x component. Should be that. And let's say we have this case. Let's say we have a vector. Let's say it is a vector b, and it is at an angle, let's say 25 degrees with respect to the horizontal. Let's say the vector b is given as should be 2 newtons. So how should we have to resolve it into components? So first thing, where the vector is coming from, we should have to present the Cartesian plane. So this is a typical Cartesian plane. It has to be presented from where the vector is coming from. And from there, we should have to present the right-angled triangle. This is a typical right-angled triangle, and these are the components that follows the same direction but in the other way around. Therefore, this is x component and this is the y component, as you can see. So using the trigonometric ratios, automatically we have bx, that is given as the vector b times cos theta that you can have, and since the component is pointing towards the positive direction, we'll have it as a positive, and that will be given as, what will be that? Now we'll have it as should be 2 cos should be 25. That is given as, 1 point should be 8 newtons. And we should also have the by, that is given as, so this is opposite hypotenuse, that is about the sine. So have it as the actually vector b sine theta, which is the same as 4, should be 2 times sine of 25. That is given as 0.8 newtons. So these are the components of the vector b, as you can see there. And the components are all positives because they are pointing towards the positive directions. And what if, let's say, we have this one as a vector? So let's say we have a vector that is going like that. And let's say at an angle, let's say it should be 30 degrees with the actually below the horizon. Let's say the vector is a vector a with the magnitude given as, let's say, 70 meters. So how should you have to resolve it into components? Well, principle remains the same. Where the vector is coming from, present the Cartesian plane. So we should have that and as that. And now, as you can see, we should have to come up with a right-angled triangle. And where now the components will go like this. So don't forget about that one. The components must follow the same direction, but in the other way around. And now for this case, this is ax, and this is what we call as the ay. And since they are pointing towards the negative directions, they are all negatives. So this is adjacent hypotenuse. That is, now we have it as ax being given as the negative should be the vector a cos theta. And why negative? Because it is pointing towards the negative direction. So the directions of your actual components will play a major role in your work. And that will be given as the negative. What is a vector a? That is should be given as 70. And the times cos should be 30. So what will be that one? We have it as 60. Negative 60.2. Should be 0.6 rather. We have it as the 0.6. Should be meters. And how about ay? It is pointing downwards, it will also be negative. So opposite hypotenuse, where are we? That is sine. So ay will be given as negative vector a sine theta, of which you can take it out there. So the direction of your components matters a lot. So be careful about that one. What if, let's say, we have, this is a typical vector. Let's say it is like that. And let's say the vector is acting at an angle theta with respect to the vertical axis. Let's say should be the angle given as 10 degrees. And let's say the vector is given as the vector, let's say C, which is, let's say, should be 10 newtons. Let me just have it as, let's say, 10 meters. Now for this case, the principle remains the same. We should have to develop the Cartesian plane from where the vector is coming from. So it should be that. Now from this case, you can see that we should have to draw the right angle triangle. And this is now, these are the components that are moving like that. And now this is Cx, and this is Cy, like that. In this case, you can see this is opposite and the hypotenuse. So what is that one? Opposite and hypotenuse. It means we are on the saw. Now why actually along x we're having so? Because the angle is against the y-axis. So for this case, it means Cx will be given as the negative. Why negative? Because it is pointing towards the negative direction. And the negative vector C sine theta. And because the angle is against the y-axis, therefore we have opposite hypotenuse, that is sine theta. And also have it in the same way, y is given adjacent hypotenuse. What is that one? That is a cos, that is k. So since it is pointing upwards, we'll have it as a positive. So have the vector C times cos theta. That you can have it as that. So you need to be very careful with that one. So just have to understand about the trigonometric ratios, the way they are working. Actually you'll be able to have it right in the correct way. And now, what if we have the vectors? We call them as the axis vectors. Axis vectors, these are the vectors that are acting in one dimension, that is x-axis or y-axis. Let's say we have, this is a vector A, which is given as, let's say, 60 newtons, should be 60 meters. So this vector can be resolved into components. You know where the vector is coming from, we should have to present the Cartesian plane. As you can see, a vector A is in the horizontal axis towards, actually is in the horizontal axis, which is x-axis, and pointing towards the positive direction. Its x component will be the same as 6 meters, and its y component will be given as L, since it cannot be resolved into two components, since it is in the actually along x-axis. And how about, let's say, if we have, this is, let's say, vector P, which is given as, let's say, 1 meters. So what did you say? Now, stream of the vector is along x-axis, but towards the negative direction. Therefore, its bx will be given as the negative because it is pointing towards the left. That is negative 1 meter. And its y component will be given as ours because it has no component along y-axis. What if the vector C, it is like that? Let's say we have the vector C, which is pointing downwards. Let's say given as 2 meters. So what did you say? So the vector is along y-axis downwards. It has no component along x-axis. Therefore, Cx will be given as L, and Cy will be given as the negative 2 meters, since it is pointing downwards. And else, if we have the vector D, which is 10 meters along y-axis up, it means dx will be given as L, and the dy will be given as 10 meters. That's how you should have to understand about the axis vectors. Vectors that are acting in what we call it as a one dimension, that is x or y. So I want you to tell me whether the components of the following vectors would be negative, or actually you should just have to tell which component of the following vectors will be negative or positive, or both will be negatives or both will be positives. Let's say we have the vector given as, let's say, a vector B acting at an angle theta. So what do you think about the components of the vectors? Which component will be negative or positive, or both will be negative or positive? You should have to tell. And let's say this is a vector C like that, and acting at an angle with respect to the vertical, just that. You should tell me the nature of the components, whether there has to be positive or negatives. And what if we have this case? Let's say we have a vector, let's say a vector D acting at an angle theta like this. So to tell whether it will have the negative or positive, whatever the components will be. And what if we have this case? Let's say this is a vector M. You should have to tell whether the components will be negatives or positives or whatever it can have. So try to have that at your own time and appreciate the beauty of that one. Now let us see how we can have the magnitude as well as the direction of the vector being actually given components. Now let's say we have a vector. Let's say it is a vector A, and let's say it is acting at an angle theta with respect to the horizon. We can present the Cartesian plane that like that as it has been already our sum. And the components of the vector A lands like this. This is x component, and this is the y component. Should be that. And what if we have been given the components? How can we be able to have the magnitude of the vector A if that is the case? Using the Pythagoras theorem, magnitude of the vector A is equal to the square of ax square plus ay square, and the direction, which is this angle, is calculated from the trigonometric ratio, which is should be opposite adjacent, that is tan. So for that case we have it as tan theta is equal ay should be adjacent opposite, that is it should be ay over ax. And what is the theta? We'll have it as the tan inverse of ay over ax. So that's how the angle will be calculated if that is the case. And now let's see how we can have the following. Let's say we have a vector, let's say a vector C with the x component given as 2 meter, and cy is given as, let's say, -5 meter. So what can you say about that one? So the magnitude of the vector C will be given as cx square plus cy square, and which is, what is the component C given as 2 to the power 2 plus -5 to the power 2, that is given as square of 4 and a plus 25, which is given as the square of 29. And from there we should have the angle theta, which is the tan inverse of, we know it is given as cy over cx. So what is that one? Now we should have the tan inverse, should be the tan inverse of, what is a cy? We have it as -5, and I divide by 2, that will be given as the -60. Negative should be 68 degrees, should be -68 point, let's say 2 degrees. So that is the angle, that is the direction. And really it is, the angle can be negative or positive, it should be that. Let's say we have a vector A with components, let's say -0.2, and ay, this is given as, let's say, negative, should be 3.9. What is the magnitude as well as the direction? We'll have it as the magnitude of the vector A being given as square of ax square square root of ax squared plus ay squared. That is given as the square root of what is ax, that is negative 0.2 square plus what is ay, negative 3.9 to the power 2. And that is what is the square root of, there should be the square root of negative 0.2. What did you say about that? So in this case, is given as the square root of 0.04 plus, and how about the square root of, should be negative 3.9. So what can you say about its square? So have it as a positive 15 point, should be 15.21, and we should have the sum of that one, which is given as, now have it as the square of 15.25. That is the magnitude. And what is the direction? Tan inverse of should be that of ax, should be ay over ax, ay over ax. That has to be, what is the tan inverse of, should be the tan inverse of, that is negative 3.9, that divide by negative 0. Should be 2. That is given as 85, should be 87 point, should be 1 degrees. So this is the direction. And now let's talk about the Cartesian plane match of 8 quadrants as well as the possible directions. A Cartesian plane, as it has been a song for a time, it is given as this. You should be well understand about this one. You should have to understand this thing properly. Let's say we have this one as a Cartesian plane, and this one is said to be the first quadrant, and this is a second quadrant, and this is a third quadrant, and this is the fourth quadrant. You should have to understand that one. Now, in the first quadrant, x values, in the first quadrant, you should have to understand that from the origin to the left, along x-axis, you know, x values are positives. And likewise, from the origin to the left, along x values are negatives. From the origin up along y, we have the positive values, and here we have the negative values. You should have to understand that one. So which means whichever, let's say, a vector A, which is in the first quadrant, its x component must be positive, which is greater than 0, and its y component also must be greater than 0. In the first quadrant, all components of the vector A must be positives. In the second quadrant, a vector A which is in the second quadrant, its x component must be negative. Must be negative, which is less than 0, and its y component must be greater than 0. That is, must be positive. In the second quadrant, in the third quadrant, x component must be negative, and the y component must be positive. In the third quadrant, all of its components must be negatives. Likewise, in the fourth quadrant, you know, its x component must be positive, and its y component must be negative. Keep that in mind. And you should also have to understand that the angles can be measured in a clockwise as well as anti-clockwise. If the angles are measured in an anti-clockwise direction, they are given as the positive angles. So as you can see, we are to move in an anti-clockwise direction. If that is the case, this is 90 degrees, and this is 180 degrees, and this is 270 degrees, and this is 360 degrees. Should be that. And if the angles are measured in a clockwise direction like this, they are negative angles. So this one will be given as negative 90 degrees, negative 180 degrees, negative 270 degrees, and the back will have negative 360 degrees. You just have to get it like that. So in whichever the case, the vector that is in the first quadrant, the possible directions in terms of the angle must be in the range from 0 degrees to 90 degrees if the angle is measured in anti-clockwise direction. But if the angle is measured in it should be if the angle is measured in a anti-clockwise direction. But if the angle is measured in a clockwise direction, then the possible directions must be negative 270 degrees to actually negative 360 degrees. In other words, the angle must be within this range. That is, if the angle is measured in a clockwise direction. Likewise, in the second quadrant, the possible direction has to be, if the angle is measured in anti-clockwise direction, must be 90 degrees to 180 degrees. And likewise, if the angle is measured in a clockwise direction, the possible directions must be that of negative 180 degrees to negative 270 degrees. That is being measured in a clockwise direction. Likewise, if the angle is measured, let's say, in an anti-clockwise direction in the third quadrant, the possible directions must be 180 degrees to, let's say, 270 degrees. If the angle is measured in a clockwise direction, the possible directions must be negative 90 degrees to negative 180 degrees. You should have that one. In the fourth quadrant, if the angle is measured in a in anti-clockwise direction, the possible directions must be given as negative, should be positive 270 degrees to 360 degrees. That is being measured in anti-clockwise direction. And that in the clockwise direction, the possible directions has to be actually 0 degrees to negative 90 degrees. So keep this in mind. And let's say we have something like this. Let's say we have a vector, a vector A with let's say x component being less than 0 and its y component being greater than 0. So it means the x component it's negative and the y component is it's positive. So which quadrant is the vector belongs to? So the quadrant with the x negative and y positive, it is the second quadrant. And what are the possible directions? The possible directions must be 90 degrees to 180 degrees. Or the possible directions can be negative 180 degrees to negative 270 degrees. That is if the angle is measured in a clockwise direction. Let's say we have a vector with component cx is greater than 0 and let's say cy is less than 0. So which quadrant is this? So the quadrant is the fourth quadrant. So what are the possible directions? Possible directions must be that of should be 270 to 360 degrees if the angle is measured in an anti-clockwise direction. Likewise, must be 0 degrees to negative 90 degrees if the angle is measured in a clockwise direction. So keep that in mind. Now, what if we are being given a vector? Let's say we have a vector A with components. Let's say given as that. Let me say with the components, x component is given as, let's say, is given as m, and the y component is given as, let's say, negative n. As you can see it here, x component is negative, it's positive, and the y component is negative. And obviously, the possible direction in which the vector A has to belong to the vector has to be in the fourth quadrant, and the possible directions must be that of should be 270 degrees to 360 degrees, or else the angle must be negative, it should be 0 degrees to negative, should be to negative 90 degrees, to negative 90 degrees. But what should we do if it happens that the angle is not falling within these ranges? So if that is the case, we just have to simply add 180 degrees to that particular case, and you observe that the angle will be within in the space field actually quadrant. If it happens that upon solving for the direction of the vector, and it happens that the angle is not within the quadrant of interest, because what will give you a clue is the components. If it happens that the components are all positives, that is in the first quadrant, but the angle that you have calculated, it is not the angle that is to be in the first quadrant. If that is the case, you just have to simply add 180 degrees to that angle you have calculated, and from there you happen that you have in the quadrant which satisfies that. And try this at your own time. And now try this at your own time. Let's say we have let's say we have a vector, let's say A, with components ax, which is given as negative 0.50 meters, and ay is given as, let's say, 1.0 meters. So try to have the magnitude as well as the direction. As it stands here, it means, you know, a vector must be in the second quadrant. And now check if the angle will really be in the second quadrant or not. If it is not, you just have to add 180 degrees and it will be in the required quadrant. And also you should have to try this and appreciate. Let's say if we have a vector m with components mx being given, let's say negative 2.1, and let's say my is given as, should be negative 170, let's say, meters, should be that. You should also have it in the same way. You know, it's either if the angle is negative or positive, but much as it is not satisfying the condition of being in that particular quadrant, you should have to literally add the 180 degrees, and the vector will happen to be in the required quadrant. So keep that in mind. So now let us see on how we can have the resultant vector as well as the direction if we have the system of the vectors. In other words, if we have several vectors. Let's say we have a vector A with its components, let's say ax, and let's say ay. We have, let's say, a vector B with its components, let's say bx, and also by. And let's say we have a component C which is of cx, and let's say we have also it as cy. And let's say we have the resultant being from the summation of the three vectors. Let's say that is the case. Let's say we have the sum of the three vectors in that way. How can we be able to have the resultant vector r for the summation of these three vectors componentry? So at the end of the day, the resultant vector r will be given as, you know, rx squared plus ry squared. And what is rx? Rx will be the summation of the x components of the three vectors, and ry will also be the summation of the y components of the three vectors. So it should be that. And the direction, it's said to be the angle theta, which is the tan inverse of, and the direction theta will be given as the tan inverse of, should be ry over rx. That's how it will be. And let's say we have the system of, let's say, four vectors. let's say we have a vector D is equal to vector A plus a vector B plus a vector C, and let's say plus a vector Q. So in this case, a vector D, it's a resultant vector of the other vectors. That will be given as the result of the vector D, which is given as, or have it as dx squared plus dy squared, like that. And what is dx? Is the summation of the x components of the vectors involved. So in all cases, you should have that one. And what is the dy? Is the summation of the y components of the vectors involved. So that is a qy. We'll have that one as that. And let's say if we have the vectors, let's say a vector r plus let's say a vector n. So what is the magnitude and the direction of the combination of these two vectors? We're not being given the result of the vectors like this. So what you have to understand is, you may think of giving any resultant, let's say resultant r will be the summation of the two vectors. Stromer will have it as the resultant vector r is the summation, or is the square root of rx square plus ry square, and the direction has to be the tan inverse of, should be ry over rx. So keep that in mind. And now let's say we have the vectors, let's say we have the system. This is the Cartesian plane, and we have it as, should be that, and this is, but let me just put that. Let's say we have a vector, let's say a vector A, that is 2 meters, and let's say we have, should be a vector B, that is, let's say 50 meters. Let's say it is at an angle of 20 degrees below the positive x-axis. And we have another vector, let's say vector C, that is 20 meters. It is at an angle, let's say, should be 30 degrees with respect to the vertical. And we have another vector, let's say a vector D, that is, let's say 20 meters. And we also have another vector, let's say a vector E, which is at an angle of, let's say 50 degrees, like that. And the vector E is given as, let's say 10 meters. And let's say we have a vector, let's say a vector F, which is 11 meters. And let's say we have a sort of, let's say a vector G, which is, let's say 5 meters. So we should have what they call it as the resultant as well as the direction of these vectors. So let's say the resultant has to be the summation of, a vector A plus a vector B plus a vector C plus a vector D plus a vector E and plus a vector G. Should be that. And we should have to resolve each vector into components from the concept of the vector resolution that we have already expressed here. And we should have to add the x components, that will be given as Rx. We should have all the x components of the vectors and also the y components of the vectors. And from there we'll have the magnitude, that is the result Rx square plus Ry square, and the direction will also be given in the same way. Try to have that, and I want to see the responses, whether it has been done or not, in the comment section below. I'll be following up. And what if, let's say, we have this case as well? Let's say if we have the vector, let's say f1, given as 20 newtons. It is, let's say, acting at an angle. We have it as, let's say, 5 degrees. And we have another vector, let's say a vector, it is acting at an angle of 30 degrees. Let's say that is f2, which is given as 40 newtons. And then we have another vector, let's say f3, that is acting in the y-axis, that, let's say, given as the 10 newtons. And we also have, let's say, F4, which is given at, let's say, 5 newtons. Let's say that is the case. Find the magnitude in the direction of the resultant force if this is the case. So resultant corresponds to the summation of the force F1 and plus the force, let's say, F2 plus the force F3 and plus the force F4. Should be that. But at the end of the day, resultant vector R should be given as the summation, should be given as Rx squared plus Ry squared. So what is Rx? We should have to add the x components of all these vectors, and Ry we should also do the same. And the tan theta, and the theta will be given as Ry over Rx. So make sure you understand better about the vector resolution. That is the key component on whatever we're talking about here. And now let's consider this case. Sometimes, let's say if we have, let's say this is a vector A. Let's say it is having 5 meters. And let's say we have, should be a vector B. Let's say it is given as, should be 10 meters. And at an angle of 20 degrees with respect to horizontal. Now, assuming that the resultant of the two vectors, I should say, assuming that we have a vector C that we don't know its magnitude as well as the direction, but upon having their summation is given as, in other words, if we have the summation of the three vectors add up to 0, what do you think is the magnitude as well as the direction of the vector C, if that is the case? Again, we have two vectors, vector A as well as the vector B. And we have the vector C, which is, we don't know the magnitude as well as the direction. But upon adding the three vectors, the resultant happens to be the 0. How do you think we can have the value of the vector should be the magnitude as well as the direction of the vector C? So according to what I've been talking about, since the resultant is 0, it means the summation of the vectors along x, ax plus bx plus cx is equal to 0. This is the first equation you should have to work on. And also in the same case, ay plus by plus cy also equal to 0. This is the second equation you should have to work on. Then we should have to resolve the components, actually the vectors into components. What is the ax? Ax is the same as 2 meters. And ay will be given as 0. And also upon resolving this one to components, we'll have bx as 10 meters times cos 20. And by will have it as 10 meters times sine 20 degrees. And since all components will be positives. Now what you have to understand is that we can have it as 10 times cos 20. That is should be 9.4 meters. And we have 10 times sine 20, that we can have it as should be 3.4. Now in this case we should have to substitute what is ax, 2, what is bx, we have it as should be that of 9.4, and what is cx, we don't know what is cx, but cx is given as should be, we should have to sum those. So what is 2 plus actually 9 point should be 4, that will be given as, now have a negative 0.4, that is 6. And using this equation we'll have also what is AY0 plus what is BY, that is 3.4 plus CY, that is equal to 0. And what is CY? We'll have it as a negative 3.4. So now we have the components of the vector C. We can be able to have the magnitude as well as the direction, of which the magnitude of the vector C will be given as the square of, Cx squared plus Cy squared, and the direction also be calculated in the same way. So keep that in mind. And let's say if we have the vector A with components, let's say we have the vector A, let's say we have, should be vector P, should be F1, which is equal to 20 newtons, and that is acting at an angle, let's say 25 degrees with respect to the vertical axis. And we have the another vector, let's say a vector F2, which is 50 newtons, let's say acting at an angle 59 degrees with respect to the horizontal axis. And let's say we have the another vector, let's say F3, which is, let's say, 70 newtons. Now, assuming that F1 plus F2 plus F3 and plus, let's say, F4 is equal to 0, what is the magnitude of F4 and its direction, if that is the case? So you also do it in the same way, the way we have recently talked about. Since the z is 0, it means F1x plus F2x and plus F3x and plus F4x is equal to 0, where you solve for the F4x. And also in the same case, F1y plus F2y plus F3y and plus F4y also be equal to 0. You solve for F4, then you have the magnitude as well as the direction. Now what if we have a case like this? Let's say if we have, should be something about, let's say if you can have the vectors. Let's say this is a vector A, that is should be that acting, you have 10 degrees, let's say 11 meters, and let's say we have another vector, let's say a vector B, which is 50 meters, and the angle is 40 degrees, should be that. And we also have, let's say, should be, assuming that we don't know about the vector B, let's say we have just this. Now if, let's say, a vector A plus vector B plus vector C is equal to 0, what is the magnitude and the direction of the vector B, and what is the magnitude and the direction of the vector C, if that is the case? In all cases, principle remains the same, in the sense that, by the way, let's have the case like this. We should have, let's say, sort of a vector B. We don't know its magnitude, but now it is at an angle of, let's say, 20 degrees. And we also have another, let's say, should be a vector C, and which is at an angle of, let's say, should be 35 degrees with respect to x-axis. So what if we have angle, actually vector A plus B plus C is equal to 0? So what are the magnitude of the vector B as well as the vector C, if that is the case? And what are the components of these vectors, if that is the case? So principle remains the same. Since the result is 0, it means AX plus BX plus CX is equal to 0. If we resolve these components, these actually vectors into components, you will see that the x component will be given as 10 meters times cos 10 And how about the by? Should be bx. Have it as this, of which bx will also be positive. That will be given as the angle b. We don't know its value, but times cos 20 degrees. And how about the actually a c? We should also do the same. We'll go like that, and of which the component x component of the vector c will be a negative, since it is pointing towards the left. We'll have vector c times that of cos c 35 degrees is equal to 0. So from there you should have to understand that we'll have 10 times cos 10. What would be that? That is should be 9.8. And the plus, what is cos 20? Cos 20 is given as 0.9 vector b, and minus, what is cos 35? It should be cos 35 is given as, should be negative 0.8, by the way, 0.8 vector c is equal to 0. This is equation 1, since vector a as well as actually b as well as c, they are unknown. And also using the same principle, it means ay plus by plus cy is equal to 0. And what are those? The y actually, and the y component of the vector a is given as that pointing towards the right, actually towards the positive direction. That will be given as 10 sine 10 degrees plus the y component of the vector b. We'll have it as the vector b sine 20, and the y component of the vector c, it is pointing towards the right. That will be given as, should be vector c sine 35 is equal to 0. And also have the same where you have the equation number 2, so for b as well as the c simultaneously, and those would be the magnitude of the 2 vector a as well as the vector, actually should be a vector b as well as the vector c. From there you'll be able to have their respective components separately. We'll have bx, we'll have by, cx, we'll have cy. So that's how you just have it. And let's say we have the following questions. Given that the 2 vectors, we have the vector a, just that, given as 55.8, and it is acting at an angle theta 1, which is 35 degrees. And we have the vector b, which is given as 84.7, acting at an angle theta 2, which is 150 degrees. Should be 151 degrees. We should find the vector actually c, such that the summation of the 2 vectors is equal to 0. So use the same principle that we have recently discussed about. And by the way, these actually angles, they are measured from the positive x-axis. Therefore, along x will have cos, along y will have the sine. So keep that in mind. And also on the second question, you should have to get that, find the result of the following set of the forces. We have F1, F2, and sort of we should have the result as well as the direction. By the way, we're just interested at the result, but in case we are told to have the direction, that is also okay. So the result is given as F1 plus F2 plus F3 and plus F4. And the way I will have the result being given as the summation, actually square of Rx square plus Ry square, and of which Rx will be the summation of the x components of the forces. So a key skill is you should have to understand about the vector resolution. That is the key skill. And by the way, since the angles are measured against the x-axis, actually from the positive x-axis, automatically along x will have cos, along y will have sine. And about the directions, a calculator will give it on its own. You observe that and that's all. So now let's extend our discussions by looking at the vector components as well as the unit vector notation. Let's say we have, this is a vector A, and the vector A is having the components. Let's say this is the X component, and let's say this is the Y component. Now a vector A in a component form, it is given as using the angle brackets, angle bracket AX, comma AY. This is the vector in component form. So wherever you see this bracket, just after that, it is a vector. And in a unit vector notation, vector A will be given as, you know, AXI plus AYJ hat. This is the unit vector notation. So if we say a unit vector, it is the vector with magnitude 1. So a vector with magnitude 1 along x-axis, it is given as I hat, and that of along y-axis, it is given as the j hat. That's how you start to understand it like that. So a unit vector notation, the vector is presented as that. So let's say if we have the vector in 3 dimension. Let's say a vector A in 3 dimension in a component form is given as, you know, AX, comma AY, and comma AZ. That will be that. And in a unit vector notation, we'll have it as, you know, AXI hat plus should be AY, that should be AY J hat plus AZ K hat. This is the unit vector notation if we have the vector in 3 dimension. Now express the following vectors in a unit vector notation. Let's say if we have a vector A in a component form is given as 2 meters, let's say, comma 4 meters. In unit vector notation, this is the same as, let's say, 2 meters I hat plus 4 meters j hat. We'll have it as that. Let's say if I have a vector A which is negative, actually which is negative 1, let's say 0 and 5, should be negative 5. What is this in unit vector notation? We'll have it as negative I hat and then plus 0j and then minus 5k hat, which is the same as the negative I hat minus 5k hat. We'll have it as that. And I can also have something about, let's say, should be, let's say if we have a vector C which is given as, let's say, half minus, let's say, 0.5 and then minus, let's say, 11. So in a unit vector notation, we'll have it as should be half I hat minus 0.5 j hat minus 11 k hat. So have it as that. So let us see how we can add the vectors in unit vector notation. Let's say if we have a vector A which is given as, let's say, AX, given as, let's say, AX I hat plus AY J hat plus AZK hat, and we have another vector, let's say vector B, which is being given as BXI hat plus, let's say, BYJ hat plus, let's say, BZK hat. Now if we have, let's say, vector A plus vector B, you know, this is the same as having it as AXI hat plus BXI hat. In other words, we need to add the vectors complementary, AYJ hat and the plus BYJ hat, and I'll have AZK hat plus, you know, BZK hat. In other words, we need to add the vectors complementary. And likewise, if we are subtracting, principle also remains the same. And let's say we have n times, let's say, vector A. What it means here is that n it's a scalar value where we have to distribute it all over. We have n times what is a vector A, that is axi hat, and a plus ayj hat plus should be az, k hat. This is the same as having it as n axi hat plus n ayj hat plus n az k hat. That is, so that's what you call it as the scalar product. It should be multiple. Actually, it should be, we call it as the multiplication of the vector with a scalar quantity. And now let's say we have this case. Let's say we have a vector A. Let's say we have a vector A given as 2i in the minus, let's say, 4j plus, let's say, 2k r hat. Let's say we have a vector B which is given as, let's say, negative 2i hat and plus 3j hat, and let's say plus should be 8k hat. Let's say that is the case. So what is the vector A plus vector B if that is the case? So what it means is that we have to add the vectors componentry. Negative 2, negative, actually should be 2 minus 2, that is cell I, and the negative 4 plus positive 3, that is negative j hat, and positive 2 plus 8, that is 10k hat. So which means this is the same as the negative j hat and plus 10k hat. That is the way to go. Let's say if we have a vector B minus a vector A. So what did you say? So principle remains the same. We'll have 2i hat minus 2. That will be given as 4i hat. Negative actually 2 minus should be what? We are having it as, by the way, let me take it back. So we are having it as negative 2 minus 2, that is a negative. We are having vector B minus a vector A, by the way. So what it means is that, let me just have to, so what it means is that we'll have, negative 2 minus 2, that is a negative 4 I hat. So 3 minus 4, that is plus 7 j hat, and 8 minus 2, that is plus 6 k hat. We'll have it as that. So this is how you should have it. And what if, let's say, if we have 2 times vector A minus, let's say, 3 minus vector B. So first thing is to simplify that one. So that will be given as 2 times, we have 2 times vector A, which is 2 times 2, that will be given as 4i hat. And the 2 times that one, we'll have it as negative 8 j hat. And we'll have positive 4 k hat. And should be that of, minus 3 times, that will be given negative 6 I hat. And 3 times that one, we'll have positive 9 k hat, and 3 times 8, that is 24 k hat. So in other words, we should have to evaluate this first, then I will have to subtract second. So this minus this minus that, this minus that. You can work it out like that point. So that's how you start to understand that one. And also let's talk about the magnitude of the vector given, let's say, the unit vector notation. Let's say if we have a vector A which is given as, let's say, should be ax I hat plus ay j hat plus az k hat. Now magnitude of the vector A is symbolized as that one, which is the square of, that is ax I hat square plus ay j hat square plus az k hat square, like that. At the end of the day, we ignore the directions, we just look at the squaring the number that we have. And for instance, if we have a vector A being given as 2I hat minus 5j hat plus, let's say, 4k hat, the magnitude of the vector A will be given as minus square of 2 to the power 2 plus negative 5 to the power 2 plus 4 to the power 2. We can have it as like that one. And let's say, what if we have another vector, let's say vector B, which is given as, let's say we have a vector B, should be, we have, let's say, vector M, that is 4I plus 2j minus 5k, and we have a vector N, which is negative I plus j minus 8k. Let's say that is the case. So what do you think will be the magnitude of vector N minus a vector M? So first thing, we should have to subtract the vectors in the other, then the final you have the magnitude of whatever you have. So try to have that one. And what if we have, let's say, should be a vector M plus 2 times the vector N? What did you say? You should have to first of all simplify that and having the summation of that one and have the magnitude laid out. And also try this one as well. Let's say if we have 5 vector N plus, let's say, 6 vector M, you should also do it in the same way. So that's how you should have to understand about the concept of the vector algebra on that point. And in some cases, let's say if we have, this is, let's say, a vector A with let's say the magnitude given as, let's say, 5 newtons, and should be 5 meters. Let's have 5 meters at an angle of 30 with respect to the x-axis. So express the vector A in unit vector notation. So which means the first thing is you should have to resolve the vector into components. This is ax and this is ay. Now using the same skills on the vector resolution, then the vector A will be given as axi plus ayj. So whatever you have on the ax, you put it here, and the ay will put it here. And for instance, we have ax being given as 5 times, cos 30, and here we have 5 times sin 30. What would be that one? What is 5 times cos 30? 5 times cos 30. 5 times cos 30, that would be given as, 4.3 meters. And 5 times sin 30, 5 times sin 30, that will be given as about 2.5. So which means in unit vector notation, we'll have it as 4.3 meter I hat plus 2.5 j hat. We'll have it as that. In some cases, you can also have the system of the several forces. Should be several vectors. Let's say if we have, this is the Cartesian plane, like this. And make sure you have subscribed to the channel, and for you to have the more contents that we make. Let's say this is, let's say, a vector f1, that is 60 newtons, angle is given as 50 degrees. Let's say that is the vector f2, 100 newtons, sort of. And let's say we have the another vector, let's say f3 at an angle of, let's say, 69 degrees. We have the another vector, let's say f4, that is 90 newtons. Should be that. f3 is given as 30 newtons rather. And we also have, let's say, f5, which is 10 newtons at an angle of 25 degrees. So express the resultant vector in unit vector notation. So how do you think we should have it? So if that is the case, we'll have it as Rx I hat plus Ry j hat. Ry j hat. So you just have to have the Rx, which is the summation of the x components of all vectors, and also Ry, which is the summation of the y components of all vectors. So you should have to keep that in mind. And for instance, if we have, let's say this is a vector A along x-axis given as 2 meters, in unit vector notation we have it as a vector A being given as 2 meters I hat plus 0 j hat, which is the same as 2 meters I hat. And likewise, if it is in the y-axis, we'll have it as a vector A being given as, a positive 2 meters j hat, since the x-axis is 0, and should be that. Now let's be talking about what we call as the dot product of the vectors as well as the cross product of the vectors. Let's say if we have a vector A which is given as AXI plus AYJ plus, let's say, AZK, and we have the vector B which is given as BXI plus BYJ plus BZK. Now the cross product should be the dot product of the two vectors is symbolized as that. So the dot product end up giving us the scalar value. So which means if we are to multiply the two vectors, and while we're aiming at having the scalar value, then we should have to go for the actually a dot product, and which is the same as we multiply the vectors componentry, but we ignore the directions. Hence we have it as AX BX and plus AY BY plus AZ BZ. And how about on the actually a cross product? The symbol for the cross product is given as that, which is the same as having it as, we have to present the components of the vectors in that case, where we have what is the x component of the A, we have it as AX, and we have it as AY, and we have it as the AZ. We have BX, and we have BY, and we have it as BZ, like that. And from there, what you have to understand is, we do it like this. And the cross product of the vectors end up giving us the vector, another vector as well. So from here, what you have to understand is that, the interest is to have the vector from the product of the two vectors. So in this case, there is a song that we basically sing. We say the first law, first column. So as you can see, we have eliminated, or we have eliminated the actually I component. Therefore, whatever it is remaining here, it is for I. Therefore, we'll have it as, should be I component, and having it as AY over BY, AZ should be down BZ. We'll have it as that. And we have it as a minus, that is according to the formula you have to understand. Now we say first law, second column, we have eliminated actually a J. So which means whatever it is remaining is for J. So have J should be IJ, that is AX, BX, AZ, BZ. We'll have it as that. Then plus, then whatever it is in the first column and the third row, actually first row and the third column, we have eliminated k. It means whatever it is meaning is for k. We'll have it as ax, bx, and ay, that is by. And from there, we multiply diagonally. That is ay times bz minus this times that, this times this minus this times that, this times this minus this times this. So that corresponds to now have it as, that of, and there should be ay times, should be bz, and minus by times c, and that should be az, and that is I minus j. By the way, we have this, and that is should be ax, and times, and that should be bz, and the minus bx times az, like that, should be j, and the plus we have ax times by minus bx times az, that is k, like that. So that's the principle behind the cross product of the two vectors. So let's appreciate how we can have the following. And consider, let's say we have a vector a. Let me use it as a vector u. Let's say we have a vector u which is given as 2i plus 2, let's say j, minus 3, let's say k. And we have, let's say, a vector v which is given as 4i plus 3j minus, let's say, we have it as 2, should be k hat, like that. So what is the dot product of the two vectors if that is the case? On the dot product, we'll have to multiply the vectors componently, ignoring the directions. We'll have 2 times 4, that is 8. The 2 times 3, that is plus 6. Negative 3 times negative 2, that is plus 6. So that will be given as 8 plus 12, that is given as 20. So this is the dot product of the two vectors. And how about the cross product of the two vectors? A vector u cross a vector v. So how do you think we should have it? So first thing, we should have to present the components. And basically, the components must be 3 components, that is in 3 dimensions. So whichever the component is missing, include that one as well. Now in this case, we'll have 2, negative 3, and for the vector u, and have 4, 3 for the vector v, and negative 2 here. And that is, then we'll have the first row and the first column. It means j has, actually I has gone. We'll have it as I, having it as 2, 3, negative 2. Then the second column, negative, he has to be negative j. It means j has gone. It means whatever it is remaining is for j. We'll have 4, should be 2. We'll have 2, 4, negative 3, negative 2, like that. And the plus, whatever it is remaining is for k. That is in the third column. That is 2, 4, not 2, 3. And from there we'll have it as 2 times negative 2, that is negative 4. We have negative 4 minus 3 times negative 3, that is negative 9. We'll have negative 9, that is I hat. And the minus, then we'll have 2 times negative actually 4, and negative 2, that is negative 4. And the minus 4 times negative 3, that is negative 12. That is should be j hat. And the plus, that is, now we have it as 2 times 3, that is 6, minus 6 times 2, actually 4 times 8, 4 times 2, that is 8, should be k hat. So which means we can have it as, and it should be, this is a plus, that is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 1 I hat, and this is a plus, that is positive 8 times negative, that is negative 8j hat, and plus 6 minus 8, that is negative, that is negative 2k hat. So this is actually the cross product. And as in some cases, if we were to have the magnitude, let's say this is the case, it means the first thing is to have the cross product, then we should have the magnitude of whatever we obtained upon having the cross product. So that's the working principle behind the cross product of the vectors as well as the dot product. And now let's finish this section by looking at the angle between the two vectors. Let's say we have, this is a vector A, and let's say this is a vector B. Let's say the angle between the two vectors is given as the angle theta. So how can we be able to have the angle between the two vectors if that is the case? So there are two formulas that we use. We have what equated as the sine theta, which is being given as the magnitude of the cross product of the two vectors, divided by the product of their magnitudes. So have that one as that. And we can also have used the cos theta, which is equal to the dot product of the two vectors divided by the product of their magnitudes. So these are the formulas that we use. In the first formula, first thing we need to have the cross product, then we should have the magnitude of the cross product, then we should have the magnitude of each vector here, then we should have everything. In the other case, we should have the dot product and sort of. Let's say if we have a vector A being given as 2i minus 10j plus 4k. And let's say we have vector B which is given as negative I plus j minus 5k. What is the angle between the two vectors? If that is the case, try to have that one. So let's say if we have the whole of this one as, let's say, 0.9, it means we have sine theta is equal to 0.9, of which theta will be given as the sine inverse of 0.9. We'll have that one, and also likewise this one as well. So try to have that one at your own time, actually in course of a practice. And let's finish with what equates as the perpendicular vector theorem as well as the parallel vector theorem, and in relation to whatever we are talking about here. Now, if two vectors are said to be perpendicular, it means the angle between them it's 90 degrees. Let's say this is a vector A, this is the vector B. These vectors are said to be perpendicular. So which means if you calculate the angle between the two vectors, it happens that it's 90 degrees. It means the vectors are perpendicular, or we call them as being orthogonal. So let's say we have the case of having, let's say, cos theta. So cos theta is equal to, dot product of the two vectors divided by the magnitude, product of the magnitude of the two vectors, like that. And if we think of the cross multiplication, what we can have is, we'll have it as, dot product of the two vectors, which is equal to vector A magnitude times vector B magnitude times cos theta, like that. Now, if it happens that the angle theta is given as 0, I should say, if it happens that the angle theta is given as, let's say, 90 degrees, we'll have cos theta should be cos 90 degrees is equal to 0. Therefore, the whole of this one will be equal to 0. Therefore, have dot product of the two vectors is equal to 0. Now, if the dot product of the two vectors is equal to 0, it means those vectors are orthogonal vectors. So if the question comes, show whether the vectors are orthogonal or not, just have to go for the dot product of the vectors. If the dot product is 0, it means the vectors are orthogonal, because the angle between them will be 90 degrees. That's how you should have it. And on the same case, on the parallel vectors, if the cross product of the two vectors is zero, it means the vectors are parallel. If the vectors are parallel, it means the angle between them, it's actually 0 degrees or 180 degrees. So whenever the angle between the two vectors it's 0 degrees or 180 degrees, it means the vectors are parallel. 0 degrees, it means the vectors are parallel but in the same direction. While 180 degrees means the vectors are parallel but in opposite direction. Should be that. So that's how you start to understand about the concept of the vectors on the quick reviews. So don't forget to subscribe to my YouTube channel for you to be actually timely updated on whatever the concept we create. Thank you.